Yeah, I'll react to that, sure. Hey guys. Okay. Preemptive like Britain's most daring World War II raid, real engineering. Sure. My name's Connor. If you're new, the original link to the video, top the description. Below that, link to the Discord. We'd love to have you. Let's learn, shall we?
Website that teaches you to think like an engineer. If we were to define World War II in just one technology, the likely winner would be aerial bombing. World War I revolved around stagnant and debilitating trench warfare that both sides sought to avoid in future. Tanks and planes arose as a way of breaking enemy lines quickly and inflict damage. The rate of technological progress for delivering larger and more accurate bombs during World War II was astronomical, but early in the war, the technology was still in its infancy. The Germans relied heavily on the Stuka dive bomber, a short-range bomber whose siren became a harbinger of death on the battlefield. It dived towards its target, planting it firmly in its crosshairs, imparting its bomb with the velocity it needed to fly straight to the target, before releasing and pulling up hard to avoid a collision with the ground. This procedure was so taxing on its pilot that the Germans developed an automatic dive flap that would deploy even...
There must be some sort of equation, right? Like, if your plane is going X speed, then how fast will the bomb go when it's, or how far will the bomb go when it's released?
If the pilot had knocked themselves, that the Germans developed an automatic dive flap that would deploy even if the pilot had knocked themselves unconscious with G-force. These tactics arose because
I gotta shut up.
So taxing on its pilot that the Germans developed an automatic dive flap that would deploy even if the pilot had knocked themselves unconscious with G-force. These tactics arose because bombing aiming technology was so primitive. Bomb sights were rudimentary and required skilled operators, having to factor in not only the speed and altitude of the aircraft, but the terminal velocity of the bomb and how it would be affected by wind as it fell. Bombing from high altitude, where the bombers would be relatively safe from flak, gave little precision to target specific buildings. This, combined with poor navigation equipment, resulted in both sides devolving into carpet bombing, causing massive civilian losses, which did little to help either side win a war. We saw in a previous episode how much effort Nazi cities put into anti-aircraft defenses, and similar efforts were made in Britain. These tactics did not come cheap. Losses were high for both sides. Barnes Wallace, an aeronautical engineer at Vickers, saw the futility in these tactics and set his focus on developing new technologies to aid British bombers in destroying strategic German positions. This was nothing new. Factories, oil storage, and transportation infrastructure were always primary targets, but Barnes wanted to create a weapon capable of destroying a target others deemed invulnerable: dams. Dams posed a tantalizing target. They supply hydroelectricity, provide water for industry and the German population, and the resulting deluge of water from the massive reservoirs would cause damage much greater than any bomb the Brits had at their disposal. The Germans were not ignorant to the allure of the dams as a bombing target. Attacks on dams had happened earlier in the war, like the one on the massive Italian Terzo Dam in Sardinia, which held back Europe's largest man-made lake and provided the Italian island with a third of its electricity. They attempted the raid in broad daylight with 8 swordfish floatplanes.
Imagine like the Three Gorges Dam, like if China was in a war, if that thing got hit. Oh my god, the amount of destruction from the water.
3 simply failed to find the target due to terrible weather, and the rest were welcomed with anti-aircraft fire, taking one of the planes down. The remaining 4 continued to the target and dropped torpedoes which travelled underwater to their target before exploding, but the dam remained standing. The bombs were simply not powerful enough to blast through the heavy concrete of the dam. To make matters worse, all dams across Europe would be protected by anti-torpedo netting from this point on. So a new method to deliver an enormous bomb capable of taking down a structure this strong was needed. Wallace spent most of his time devising devices to take on this challenge and took several things into consideration when designing his bombs. Explosive pressures decay extremely quickly, and thus to ensure damage to the structure, it must be as close as possible. Pressure waves propagate through denser mediums far more efficiently, and thus explosions underground or in water will be more powerful. And finally, doubling the size of the bomb does not result in twice the blast radius. To increase the blast radius drastically would require a drastically larger bomb. His design ethos from here was simple: design the biggest bomb his planes could carry and have them detonate underground or in water to maximize their effect even further. He presented his ideas in a 1941 paper, a note on the method of attacking Axis powers, with the primary focus on a 10-ton...
Guys, that's why depth charges are so destructive for submarines, right? Is the same concept that the shockwave underwater is so much more deadly,
Earth
powerful.
Note on the method of attacking Axis powers, with the primary focus on a 10-ton Earth-penetrating bomb that would be dropped from 40,000 feet. This was the most powerful non-nuclear bomb ever used until just last year, and 42 were dropped in the final year of the war that helped cut German supplies to the front line by destroying viaducts and...
Is that actual
non-nuclear bomb ever used until just last year.
Look at all the craters.
And 42 were dropped in the final year of the war that helped cut German supplies to the front line by destroying viaducts and railways. But Wallace is remembered for a different bomb. The British government hired the Road Research Laboratory, a civil engineering firm, to begin experiments to find the smallest charge needed to destroy the Moona Dam. They constructed several scale model dams and used abandoned dams in Wales to find their answer. They found that a 10-ton bomb exploding 50 feet from the dam would not destroy it, but a 2-ton bomb could do the job if it was placed directly next to the face of the dam. With torpedo netting installed, this job required precision that had not been seen before, and the method that was devised would break all convention. Barnes decided the best course of action was to create a skipping bomb that would bounce over the protective
I knew it.
netting
I've
before
heard of this
sinking
somewhere.
next to the dam and exploding. He concluded that the mines would have to impact at less than 7 degrees in order to skip, and all subsequent bounces would have to be below 7 degrees to ensure the bomb continued until momentum was lost. The bomb would be given backspin prior to release in order to take advantage of the Magnus effect, which is lift created by a spinning body. Spinning the bomb provided stability, like a bicycle wheel in motion, helping the bomb remain on a straight trajectory, but the lift the spinning provided was far more useful. By adding lift...
Interesting. So why do they spin it that way instead of the other way? 'Cause I guess at first you'd think, oh, spin forward because then it'll carry forward, but maybe it wouldn't skip as well. Maybe it would like go right in.
The bomb provided stability, like a bicycle wheel in motion, helping the bomb remain on a straight trajectory, but the lift the spinning provided was far more useful. By adding lift, the bomb's trajectory gained more horizontal motion, and its angle of impact was reduced, both of which aid skipping and allow the bomber to release the bomb sooner, giving them additional time to escape the imminent explosion. Once submerged, the remaining spin would help push the bomb forward, ensuring it stayed in close contact to the dam wall. This wholly unconventional bomb posed some design challenges. Any spinning object needs to be precisely balanced to prevent vibrations that could potentially break it or interfere with its operation. To aid this, Barnes' early spherical designs were scrapped in favor of a drum, which could be more easily manufactured and balanced, while also aiding in its release mechanism. The bombs were fitted to Avro Lancasters, which were modified to accommodate the bomb. The bomb doors were removed to fit the bomb, which would protrude below the plane for the duration of the flight. The lower ventral guns were removed to reduce drag, as the mission would be flown so low to the ground that they would provide no protection against fighters. 2 V-shaped mounting arms were then attached with free-spinning disc mounts, which
I was
would...
surprised they didn't use more like a pill capsule shape, because obviously they know more than we do. They're in the middle of wartime and they're very smart engineers. But I would have thought that like if it hit an edge, it would just stop the momentum.
would mate with the support rings on either side of the bomb.
I gotta stop talking.
They would provide no protection against fighters. 2 V-shaped mounting arms were then attached with free-spinning disc mounts, which would mate with the support rings on either side of the bomb. An off-the-shelf motor, typically used to power hydraulic pumps on submarines, was used and connected to the bomb with a pulley. Finally, to release the bomb, Barnes needed a way of unmating the bomb from its spinning mount. This was done rather ingeniously. These mounting arms were stabilized with a tensioned wire, which kept them firmly mated with the bomb. When the bomb needed to be released, the tension was released with a solenoid-actuated grip. Compressed springs would then force the arms to swing outwards by just a couple of degrees, enough to release the bomb. The bomb was now ready, but little time was afforded to the crew that would man the plane that would carry them. A new special squadron was created specifically for this mission, formed with some of the most experienced pilots the RAF had to offer. And this experience would be needed, as the entire mission would be flown at extremely low altitude at night. Navigators had to learn to navigate with limited information, often little more than the bomb aimers calling out landmarks they passed over. To increase the time they had to train, their Lancasters were fitted with blue plastic screens to the windows to limit visibility and light during the day. After many test drops, the crew were finally informed of their target on the morning of the attack on May 16th. That night, they would take off from RAF Scampton in 3 waves with a total of 19 aircraft. Little would go smoothly from here. The first of the planes was lost just an hour into the mission, when it strayed off course over the heavily defended Texel Island off the northern coast of the Netherlands. 2 planes collided with power lines and cables as they flew low over the Dutch and German countryside. Another plane flew so low as across the North Sea that the low-slung bomb collided with a wave, dislodging it and forcing its crew to return to base, followed shortly after by another plane badly damaged by flak. At this point, the entire first wave of planes had failed their mission, but others were finally reaching their target. Gibson, the commander of the squadron, was the first to arrive, flying at 370 kilometers per hour, just 60 feet from the water. He successfully dropped his bomb, which bounced 3 times before sinking and exploding, sending a gigantic spout of water over the dam, but it had sunk too short of the dam. On the following run, a bomb bounced over the dam and destroyed the powerhouse at its base, while the Lancaster that carried it crashed into flames after being struck by flak. Gibson at this point circled back around to act as a decoy for Henry Young, whose bomb veered off towards the banks of the reservoir. On the 4th try, the squadron finally got a direct hit, but another blow was needed to collapse the dam, which came shortly after as Gibson and Mickey Martin flew decoy runs alongside Maltby, who scored a direct hit on the already crumbling dam, sending 330 million tons of water into the valleys below. With their first target down, the first wave continued onto Eder Dam, with 3 bombs left, which was all they needed. After 2 unsuccessful attempts where 1 bomb damaged the plane that was dropping it, Knight's Lancaster came in at the perfect speed and altitude, releasing his bomb before quickly pulling hard to avoid the 300-foot hill directly behind the dam. The first wave were now out of bombs and made their journey home.
Anyone who's ever skipped rocks before, which I'm assuming is most people, I feel like it's a standard. I'm a champion. I'm not actually, but I love skipping rocks. But obviously the altitude at which you release it is going to have an enormous impact at the speed and length that the object is going to travel. Like if you ever try and skip a rock and you throw it from it's best to kind of get close to the ground and throw it so that when it makes contact with the water, it's going as parallel to the water as possible so that it can skip nicely. And just, I'd imagine like a single yard or 1 meter above could make a lot of difference in the speed that it travels. And I had another question, but I also know that this would make a problem for your own airplanes. But seeing, how some planes were destroyed by like electricity cables and whatnot, telephone wires, they were flying so low. I feel like we're at 937 here. I feel like, where is it? Come on. Where it had the netting, right here. I was at 937. So they put the netting in, and they didn't think to, do anything above it. They didn't foresee the Brits coming up with a skipping bomb, but putting just wiring above in the airspace of the dam, going up to it to block any planes. Obviously, they didn't know that they were going to try this, which is fascinating. It's like they both know the dam is going to be a big target because of the power it generates and the destruction it will cause when it breaks. And so, all right, we need to fortify that. A lot of anti-aircraft stuff, I'm sure. And then, okay, what about a torpedo? Then they make the netting. And then the British are like, all right, they have the netting. We can't use a torpedo. It's just fascinating and really cool how humans and how we in warfare just like we go, okay, they're gonna do this, we do that, and then we do this and we do that, and it's really cool. I forget the main thing I was gonna say. Oh yeah, the wiring, but that's hindsight.
Out of water over
All right,
the
I was
dam.
at 937 or 947. Let's go 937.
Speed and altitude, releasing his bomb before quickly pulling hard to avoid the 300-foot hill directly behind the dam. The first wave were now out of bombs and made their journey home, but this leg was just as dangerous as the already damaged plane was shot down soon after, and 2 more Lancasters would be brought down by flak on their return leg. The third wave lost 2 planes before reaching their newly assigned target. One strayed over the city of Ham and was gunned down by anti-aircraft guns. Another was lost over the Netherlands. What remained mounted an unsuccessful attack on the Sorp Dam before returning to base. In all, the British lost 8 Lancasters in the raid, killing 53 men, while another 3 who managed to survive their crashes were taken prisoner. But the damage inflicted on the...
That's pretty great. Oh, Goering said no enemy plane is going to fly over Reich territory, and then just putting that quote right on the plane flying over Reich territory.
While
Love
another
it.
3 who managed to survive their crashes were taken prisoner, but the damage inflicted on the Germans was far greater. The resulting floods
another
wreaked
question.
havoc on the Ruhr Valley. Every bridge downstream for 40... The resulting floods wreaked havoc on the Ruhr Valley. Every bridge downstream for 45 kilometers was destroyed. 10 factories were destroyed and a further 100 damaged.
Jesus Christ. No bomb can do that until you got nuclear weapons, that is. No, but I had a really important... I know I'm pausing a lot, but this is... How were... obviously, you know, the German treatment of undesirables, right? People they sent to camps was awful. How Soviets treated prisoners of war was awful. How Japanese treated prisoners of war was awful. And I'm sure there are a lot of cases of Americans and British people not treating prisoners of war well. But how did Germans treat British and American prisoners of war, especially British? And how did the British treat German prisoners of war? For some reason, I have a gut feeling that they would have been treated a little better than had Germans caught who they thought were, you know, undesirable. But I'm curious about that. Are there any like insane horror stories to the level of what the Japanese did or Russians did? And I'm not, you know, obviously I'm sure there's a lot of stuff America's done that I haven't heard about because I wasn't taught about it, but yeah.
Mines were flooded and an estimated 400,000 tons of coal production was lost. Acres of farmland were wiped out and over 1,500 people died in the resulting floods. All this damage with just 19 aircraft. This was precision that had not been seen before. However, some have questioned whether the raids were worth the loss of life. Many of the people killed in the floods were prisoners of war in forced labor, and others are quick to dismiss this raid as a failure because the Germans recovered so quickly, taking just 5 months to repair the dams.
I wish seeing faces is obviously if you colorize them, it's even more amazing. But I wish we could see the faces of people hundreds of years ago. Like I wish we could see the faces of Napoleonic soldiers or imagine Roman soldiers. Like just it's so hard to think of them as real people, but they were. And
because the Germans recovered so quickly, taking just 5 months to repair the dams, in time to ensure the reservoirs would fill for the following summer. But these people seem to ignore the immense amount of resources that had to be diverted to repair the dams. They were repaired quickly precisely because they were so vital to the German war effort that it was worth shifting thousands of workers and materials away from the front lines. D-Day, which would come
and
just
the
a year...
speed at which, and I'm sure the speed at which you repair that dam is going to either demoralize your enemy or what's the opposite of demoralize? Moralize? Or hype up your enemy in that, they're taking a long time to repair that dam, which means they're not But if they repair it really quickly, you're like, oh god, they're still well functioning.
After this raid could have gone very differently if those resources had instead gone to fortify the beaches of France even further. These 19 bombers, pound for pound, did more damage to the German war effort than any other British air raid, thanks to the precision they had been engineered to achieve. And precision would become the focus of many of the war's greatest engineers once the war had ended. After all, the moon was much further away than any previous target. Once again, for this kind of topic, a smooth segue isn't appropriate, but videos like this would not be possible without Brilliant. My goal for this project has always been to inspire the next generation of engineers.
You should use any promo
Brilliant
codes,
is the perfect partner for this channel because their courses are designed to educate you from knowing nothing to having a deep understanding of the topic. Perhaps you feel you could brush up on your statistics skills, a valuable analytic tool that could help you academically and in your everyday life. This course on statistics guides you through problems that are broken into digestible sections with fun problems to test your knowledge along the way.
Thanks for watching, guys.
This is
And
just one of many courses.
Please, any video I watch that has a sponsor, I feel so lucky to be able to actually react to other people's content and watch it with you guys. Just least we can do is if I'm not saying to buy it if you don't want it, but if you do want it and you got the idea from here, just please use any promo code that the channels I watch offer.
On Brilliant, with more
Means a
courses
lot.
due to be released soon on things like automotive engineering and Python coding. If you've been inspired and you want to educate yourself, then go to brilliant.org/real engineering and sign up for free.
I talked a lot in
The
that
first
video, but
73
it was
people
stuff
to
I
go to
really
that
wanted to
link
say.
will get 20% off their annual premium subscription. As always, thanks for watching and thank you to all my Patreon supporters.
Thank you for making. All right, guys. Love y'all. Hope you're all doing well. I know I paused a lot, even in my opinion. I think I paused quite a bit. But if you could answer any of my questions, I'd really appreciate it. And I'll see you guys next time. Bye, guys.